I'm going to record it. Bene, buongiorno. Okay. Photonic device. A lot of people. Thank you to be here. Should I use the microphone or can you listen me down to the... Okay, I try to keep the voice a little bit louder and avoid my... In case, just let me know. Okay? So, course... I'm doing this course since, I guess, 1997 or 98, so it's a number of years now, almost 20, yeah, so this reveals a little bit my age. And, well, it's not always the same. I work in the field. I work in the field, so I try to keep the course update and align with the field and with the expectation of the students. So I'm trying to do my best to follow the evolution of the field. So first of all, the course is open to telecom, to electronics, and to physics. So we'd like to, and it's the first year and the second year. So we'd like to understand. First of all, are there physics people? Okay, just one, right? So maybe we have to discuss a little bit after maybe at the break, because for you it's 5 credits and it's called the optical interconnect, and so we have to. I want to explain you, but personally, yes, you are the only one. Then electronics. 3, okay, good. There should be 6, but probably your friend are busy with other courses, I don't know. Okay, and all the other are from telecom. I guess. Right. Okay, how many did not follow with the optical communication? Not. So you are at the first year.
Okay.
You are allowed to speak Italian. I must speak English, but you can ask in Italian. So the course is on photonic device, optical device. It was born really for optical communication, for telecom. But the optical component, optical device are really penetrating in many fields. So it is telecom, device for telecom. But the technology and other applications are very general. So I will stay attached to the optical communication field. And most of the devices are presented inside the optical communication, so with some telecom language. So in case for the electronics guys and those who did not follow the optical communication course, that is not mandatory, obviously. In case of problem, in case of doubts, in case of, in any case, just ask me and I can stop and explain you and tell you. Okay. Then as I told you, I work in this field. I like this field, probably too much, and so I try to keep the course. Part of the course is really educational, so at a master level, and some other part is at a research level, so more deep, more advanced. So I like to give you as much as possible information and keep you passionate on the field, trying always to explain what is absolutely used and is accepted by everyone, useful for the real application, for in-the-field application, and what is instead of the research level. There is a lot of research in the field, so I try to pass you the information on research that I think will become useful for the market, for the product, for our field. It's difficult to say at the beginning. So in case I'm wrong, it's just informations and interesting aspect. Some other case maybe we will see this device in the market in a short future. Short because things are really going very, very fast in this field. Some part, especially at the beginning, are very, not very, but try to keep more formal with formula, with derivation of the formula, with formal explanation of the physical phenomena. Some other parts are really more at the physical level, without going down really to the detail of the mathematics and to the yes, basically to the mathematics behind. And toward the end of the course is really, I increase the level. I try to keep a research language and keep a very high level. And I assume that everything we have done till that moment is acquired by you. You know how to use it and so on. The message is a lot of information, more than 10 credits, but don't worry. What I would like really to pass you is the entire panorama and give you a tool on how to access to the information. And you have how much? 18 years of school behind, probably more, So it's important that you know where go and pick the information. Don't try to remember everything because it's impossible. Well, at the end there is an examination, so you have to do the exam, but it's not what I ask. What I ask is that you understand the physics behind why sometimes we keep a direction instead of another one, where go and understand the teeny detail and the more formal part. And so someone say that the knowledge is everything you remember once you forgot everything. No? So this is what I would like to pass. Let's try at least. Okay. What else? Oh, the starting. The philosophy of the course. We will go that now inside the program quite in detail. It is mainly divided in 3 parts. One part is on, I call it the electromagnetic part, on the waveguide, the propagation in waveguide, the building block of our device, and this is the more formal part. Then we move to the more circuit part, so photonic circuit, clearly, and how to build, to realize, to implement some functions. And the last part is an even higher level, and the application, the function that are needed in an, let's say, optical communication system, and then we will see what I mean for optical communication system. Photonics is really penetrating a lot, so we will see in a while. Till a few years ago, optical communication means a long distance. Now it's really penetrating, and if you think to data center, for example, the optical communication is over few hundreds meter or few tens of meter. And in the more advanced research and application of the area, you are really on communication at a distance of millimeter or hundreds of micron. So in some case, if you have to connect 2 devices that are few millimeter apart, it's more convenient to use an optical link, a few millimeter, okay, an optical link rather than an electrical or electronic link. So this depends on the application. And so you see the penetration of the photonics in the communication. Okay. So we will talk about this part, and this is called what is called the optical interconnect or silicon photonics, because you are going down to the level of device. Device typically are in silicon, so we need to use the silicon for the communication, for the link. Okay. So now, if you have any question, please stop me. I would like to have, and the previous year was quite successful, an interactive course. So give me the questions, give me the direction, give me the subject and the topics to talk about, if I can. And so, if you have any questions, please. Any questions? Now you want to go in the detail of the context of the course.
Do we see in biomedical applications of optical devices in this sense?
Not really, even if we will see some application where biophotonic sensor can be really implemented in photonics with integrated optics. I have activity research in biosensing, so I'm involved in the field. But so if there is really an interest, I can maybe do a couple of lessons on this. But every time I can touch other field, other application, I will try to do. No? So first of all, I ask about yourself, but myself, well, I teach this course since a long time, and mezzi trasmissivi o elettromagnetismo in the laurea degree, so in the first level. Second year is a 5-credit course for informatics now, as you know. Try to explain the difference between the various transmission media, so the difference between a cable, an optical fiber, or a free space link, and so on. Why this one does not start? No.
Also you need to, for MacBook, there is a line, you need to plug and unplug.
I've done it already twice, but there is no sign.
No,
I don't see the sign, but I can. Give another one. Yes. So, I teach these two courses, and concerning research, well, you understand, I work in this field, really related to optical communication or telecom since a couple of years ago, even more, 3 or 4 years ago. And then I started to move towards other field. I have this activity on biosensing, an activity on microwave photonics. This is a very new field that is the realize microwave device using photonics. So instead of do a signal processing in the microwave regime, convert it to optics, do signal processing in optics, and convert back to microwave. It seems a long way, but sometimes it's much better. Well, I'll talk you about the research during the course. Um, okay. This slide. I forgot my pointer at home. Okay. Uh, this slide is to okay. Present the field as I like to present the field in this way. No, in photonic device is really I mean this area. But photonic today means the entire chain. So from material to the technological process to the electromagnetic analysis of the device, of the waveguide, to the building block, the circuit to realize some kind of function. And once you arrived here, it's just the starting, because then you have to put the device in a package, in a box, because people wanted the device in a box, otherwise they cannot use it, and go towards a module and the system. So we will focus on the device. The course is on the device, but you cannot think to the device alone. You cannot talk with other people. If you just know this language. So it's extremely important to know why you do photonic device without the potential, without the limits, and which is the language to talk to people towards the application. This is a telecom application, but any kind of application, and towards the lower level, the technological level, the material and the process level. In electronics and also in microwave, this is more well defined. People that works on the device, on the circuit, basically work only on that field. But this is not yet possible in photonics. We are at the beginning of the era of the photonics. And it's very important that you know the reason to use photonics or the reason not to use photonics. There are reasons that bring away from photonics, and this is important too. And the language to talk with the neighbor, otherwise it becomes really difficult. So we will try to touch the entire field, even if the material and technology will be a constant through the entire course, but we will not go too much into the detail. We basically start from here. And we go to the application, but we stop mainly at this level. Okay. First of all, before starting, this is the I hope it's fine for you. You have overlap, I guess. Yeah.
Only 30 minutes. Only 30 minutes today. Today, 30 minutes we have overlapping.
30 minutes today. So how many overlap in this 30 minutes? Just 2, 3? Okay, with what?
Business knowledge system.
Business information system.
Computer graphics for
30 minutes at the beginning.
Yes.
So you would like to start at 2 instead of 1.5. Because usually on Monday, on Wednesday there are any overlap? Wednesday, no overlap.
No.
Okay. So if everyone agree, I can start at 2 o'clock on Monday. Quando?
Facciamo ultimina dopo,
Alle 4.
forse iniziare a
Sì, sì, ma voglio sforare l'inquadratura vera. I reduce by half an hour the lesson on Monday. I do not shift, I shrink. It's fine.
That's fine. Yes. Perfect.
Okay? So Monday we start at 2 o'clock, so you have more time for the coffee, and we are at 4. Okay, good deal. It's too early, 8:30 on Tuesday? Hope not.
No.
No, you are used to do, and mercoledì 3 hours like this. Okay? Good. Then, so we start today, okay, here, with the red arrow. So we have 6 weeks full, 1, 2, 3, 4, 5, and 6. Okay, 6 weeks. Then there is Easter, a single day here that I probably will skip, and then another
Good days.
we will see this one probably. Then the last week of April is green, is vacation, is I don't know what. And then the first week of May that is should be dedicated to seminar or other activity, and there should not be any lesson. And then another 1, 2, 3, 4, 5, 6, and 7 weeks full. My goal is to finish here, so a little bit before. I will not go to the end of June. So if I can stop here, the lesson is, I think it's a good for everyone. So 6 weeks, a break, 6 weeks. It's a lot. Okay?
Are there midterm exams or not only the total at the end?
Do you want a midterm exam?
No.
Yes.
No.
Yes.
I mean, usually the exam is only one at the end, oral. This is the exam that I do typically in this course, because students are not used to do oral examination, so I prefer to stress a little bit the student with you have to, you cannot write the entire life. You have to interact with people at some point. So you have to do oral interaction with other people. However, this year it's a large class, so it's really up to you. How many want a mid-term? So why not?
But it can be preferable. Someone wants, someone doesn't want. Can we do like?
Yes, sure. It is the. I want to keep the same modality, the same technique of exam for everyone. Should be not. It's not very fair to use two different kind of examination. If you like, I can do it in this week, for example. Huh?
Midterm.
Midterm. On the first part. Written examination and oral examination at the end. Okay? No?
No.
No.
Why not?
So, Professor, what happens if, let's say, somebody writes an exam and it's not good?
We can have the total one.
Go to the total one. As usual.
Professor, as I understood, you are proposing to have a written in midterm
Yes.
and oral in the end. Because in the end of the beginning of May, we will have another exams. Guys, we have chat and piece of information, data mining. So
Everyone is busy with exam. Me too.
Yeah, it's like a,
I have a deadline. I have a lot of things to do. So, well, it can be a. I didn't thought about this, but it can be a good option. Maybe some of you wanted to do a midterm, and someone prefer to go to the end, and
we can vote.
But for those who want to do the total one, it's not a problem if someone else.
you are not
does
obliged.
No. Okay,
You are
that's
not
fair.
obliged.
So what's the problem?
It's fair.
Yes, not a problem. Okay, so a written mid-term and an oral final one with the entire program or just a portion in case you pass it or not the first step. And usually I don't fix a date for the exam. I give you a number of possible dates. I prepare a doodle, no more than 8 or 10 students per day, and you choose when to do the exam. Typically is 2 days per week from the end of June to end of July. So it's very flexible for you. On one side, the other side, my experience that students, if not, are not forced with a deadline, prefer to do, well, maybe next week or the week after, and they arrive to the end of July. So try to manage your time carefully.
Professor, in case I take the part one, which is written, if I take the part one which is written, if I take the part one of the exam, which is the midterm, at the end of the semester, I'm going to take oral. Is the oral going to be for the total?
No.
Or
Well,
it's
if
just
you pass it the first, if you accept the mark of the first, no, it's only on the second part. Okay? So we decide how to do the examination. That's a good point. Any other question on? And then you will see how I explain. I'm not very rigid and formal. I always forget to pi and the sign no because it's important in the formula. And the most important part is the language, is the physics behind, is why you take a decision and the direction rather than another one. Okay? And that you are able at the end to talk with the exam. The oral exam is typically like this. I wanted that you interact with a person that know photonics but is not expert in photonics, like me, with the right language. And you explain me what I ask. With the proper language, with the proper structure of the your explanation, okay? This is important. And it's not at all, unfortunately, common with students. They prefer to write a sequence of formula, or they prefer to start at the real beginning and then they get lost. So try to. Okay, so.
Excuse me, Professor. About the written part, the written exam, is it in open book or something like that?
Open book.
I mean, can we bring your notes for the written exam? Or
if you want to bring the notes, the level will be higher.
yeah. No.
So
No.
you can decide. But obviously, if you have the book, you cannot just copy. The program. I lost it. Okay. So let's move to the course and the contents of the course. If you well, if you decide to do this course, I guess that you read the program. So, and this is the program that should be available in the website. And well, as you see, optical component, optical circuit, and optical interconnect. The three level, the application level. So I will try to touch the technology, the building block, the device. Everything is useful for optical communication and the communication, telecommunication, datacom, optical interconnect. What is useful for other applications like sensing, like optical processing, like biosensing, etc. everything, let's say, except the laser and the photodetector. This is not part of the course because it's too much. Huh? So everything is the, let's say, the passive area. I will touch the amplifier, but very rapidly. When we talk about the indium phosphate technology, indium phosphate platform, and basically the passive component, the modulator. From my point of view, the modulator is a passive component. It's not active because there is no conversion electron photons, and I will just touch the photodetector. So this is basically the contents, and I try to divide like this. This is more detailed. So I would like to keep this week to explain the framework. Why photonic device, what you study, the optical communication, other field in a very general and broad sense. This should be done at the end because at the end you would appreciate much better this part. Well, it's really very boring to start with equation and optical waveguide without knowing why we study this. So I prefer to give you a week of framework and scenario, and then start with from the bottom and goes up. And at the end of the course, go back to this part. So then 1 week on waveguide, optical waveguide, no Maxwell equation, so don't worry. And then we start with the building block, so the directional coupler, the wide branch, or the small device that are useful to make circuit. So we start here with more complex circuit, and then we pass it to advanced component and device, filters, delay line, cross connector, optical drop multiplexer, software-defined photonics, etc., from the point of view of the technology and the circuit. And then 1 week of technology, the most important technology and material used in this field. And 1 week dedicated to non-integrated optics device. All the rest is on integrated optics, but there are components also that can be realized with other technology, optical fiber or free space and micro optics, and I cannot not talk about this important part. So these are the 6 weeks before Easter.
Are there any materials about the subject, or we just need to focus on what is developed during the lecture?
I'll show you at the end of this slide. No, I'll go back later on this. And then another 6 weeks. I don't want to use the last one. Well, the first one is once again on device modulator. We will do the modulator quite deeply. The modulator is an important device itself. Is one of the key devices, and it is a nice device because it's a mix between optics, microwave, and electronics. Because you control the optics through the electronics, and this is at very high frequency. modulator today can go up to 100 gigabit per second. So the problematic of microwave, I don't know if some of you do follow the course on microwave. No. Okay, so we'll try to not to go too deep in the detail of the microwave aspect of modulators, but it's important part. And then we go to more, I don't say philosophical part, photonics integration, what, why, how, and we touch this all over the course. And especially silicon photonics, CMOS compatibility, that is really the new fashion topic today. And I would like also to finish touching other field of the photonics, so the terahertz field, the plasmonic, biosensing, new material, nano antenna, optomechanics, just to really make you understand how broad is the field, and we are really at the beginning of this topic. Someone say that this is the century of photonics. The previous one was the center of electronics, and this one is the century of photonics. And, it's quite amazing what people are really searching and researching on. So this is the part that you were interested. So the textbook. I have some note in Italian that you can download from the website. I have a website. I think a good website that we keep updated with all our activities is photonics at dave.polyme.it, and under teaching you have a lot of material. Once again, don't worry. Most of this material is protected by password, and the password is coerenza. Small capsule.
See.
Is it up?
Yes, the small.
Okay.
So then
The PDF or the other material is protected just because there are parts of paper books or slide from someone else, and so it's better to protect it. And it's coherent, you can download it and unprotected with this. And so the lecture notes are in Italian, even if last year a group of students translated into English. So I will add the note in English. I've not checked carefully everything, so it's not under my responsibility, the English note, but are available. And you find most of the course on these notes. And then you have a lot of other slides. I try not to use a slide, even if, well, this week will be all a slide. But I try not to use too much the slide. And the slide is just to show some picture, or to, even if some topics, I have some topics very well organized in slides, so I use the slide. But I try to use the book. So most of the material that I use is there.
Quindi sai questo istituto italiano
L'esame può essere sostenuto in italiano, in English o in francese. Ok? Anche la prova in italiano. La prova intermediate, mid-term. I also suggest yes, I also suggest here some book. The first one, Theodor Tamir, it's a very old book, 1990, but it's really a Bible. I like it very much, very rigorous, very fundamental. I like it. I mean, if you want just to follow the course and pass the course, you don't need the book. But if you wanted to go a little bit more in the detail, or you want to do the thesis in this field, or you want to become an expert, you like it, I succeed to pass my passion. Thank you very much for in the field. These three books are very good. The second one is another quite complete and good book, and this one is really centered on filters with a signal, digital signal processing approach. But really, the note and all the material here is more than sufficient. Okay? Any other questions?
Everything clear?
Okay. If yes, I think that I finished this part. I want to yes, this too. Most of the lessons are given by me, and a small part is given by a postdoc, student that do the master thesis and then the PhD, and that now is with me, that is expert in indium phosphide technology and more active device. And I will try to invite also someone to give a short seminar or on a very specific topic, a very specific subject. And also, I do my research activity in Via Colombo, and there is a building with a quite strange building, we call it Cremlino, and is where there is my labs, and also the Micro and Nano Technology Center of Politecnico of Milano. It's called Polyfab, and is something that we establish. If you want, this is a happy end of a bad story. We succeed, me and other two colleagues, Professor San Pietro from electronic and Professor Bertacco from the physics department, succeed to recover a part of the machine of the clean room, technological facilities from the plant of Pirelli Labs. The Pirelli, one of tire, was very active in photonic device from 2000 to 2008, and then they dismissed all the activities, unfortunately. This is the bad story. But the happy end that we succeeded to have a lot of these technological facilities, and the director of the Department of Physics and the Department of Electronics, together with the rector, decided to invest and give us a space to establish a micro and nano technology center in Poligny. The first one is not common in Italy and is quite large, is 400 square meter, and is now fully working, we have to say, since 1 year. And so in case you are really interested in this field and in the technology, you will have the possibility to visit this center, and is really advanced and complete. We have everything except doping and the doping of the silicon, so we cannot make a transistor, and epitaxial go. But for the rest, there is the entire chain to move from a wafer to a prototype. So the lithography, the deposition of the film, the etching, and some facility for the backend, and arrive to really a device, a prototype. That is a quite unique example in Italy. That we are very, very proud of this big work on this. And you will have the possibility also to visit my labs. I have 77 square meters of labs for photonic device and photonic characterization. So I think that I touched most of the general part. Any question? Any?
Ragazzi, l'anno scorso mi ha detto che era possibile fare anche un progetto. Quest'anno non è prevista la cosa.
Becoming more and more complex to make to assign you a project. A few years ago, I had a few students, so I tried to keep the student on track, assign a small project during the course. But now you are 74 and becomes difficult. So one possibility is to shape the mid-term test, mid-term exam around the project. This can be an option. But the project that I gave in the past was mainly to keep the student aligned and keep them on track, not for really an evaluation. So I can assign easily small task. I usually try to trigger you with study this and this, or try to do a simulation on this. I give you some software tool to do to go deep inside some aspect, and this is the part that can be used as project. Okay, good. So you want to stop 10 minutes before we really started the course, or maybe yes. Yeah.
Il giorno du hast ein
Что сказал, мадам, скажи мне.
Я пока что не чую. А, в начале?
Das ist
Он
ein
просто говорил про курс, да. Not yet. I will, so when I can go, I will now ask when I can go to these what? It's about the problem. No, maybe during the alphabet is not to say something.
Oh, okay. When you come at the time, and how you?
Yeah, he just came and started.
Okay. He shifted the time, shrink the
So
calculation.
yes, he also shifted the time.
The
Not
class will
shifted,
begin.
but he just
Shrink
reduced
the time.
Yes.
Now the class will begin at 2
Begin at 2 o'clock.
and finish at 4. No class overlapping for me. At 2 the class will start. He shrink the duration of the class. No overlapping, tension free. And I hope just I will